Hello students, welcome to the next lecture of statistics. Today we will start the new topic, that is probability distribution in statistics. So I hope that you must be aware about probability. Probability basically is the chance of occurrence. So let's see with an example. For example, if we toss a coin, then we have the chances that we get a head, or we have a chances that we get a tail. So what is the probability that we get a head on one toss of a coin? So in one toss we have two possible chances, and the favorable case is one, that is head. So the probability is given by the ratio of the favorable cases with the total number of cases. So the probability of getting a head on a toss of a coin is 1 upon 2. Let's consider another example. Let's say we have a dice. So what is the probability of getting a 4 on a throw of a dice? So getting the 4 on a single dice, we have one favorable case, and there are total number of 6 cases from 1 to 6. So the probability of getting a 4 on a single throw of the dice is 1 upon 6. Let's see once again, what is the probability of getting either 2 or 3 on a throw of a dice? So now the favorable cases are 2, because one favorable case is of getting 2 number and other favorable cases of getting 3 numbers. So total number of favorable cases are 2 and total number of cases are 6. So this is the probability of getting either 2 or 3 is 2 upon 6. So that is the probability. So now we'll have to study the probability distributions. So probability distributions are of two types. One is discrete probability distribution and the other are continuous probability distribution. Now the discrete probability distribution is further divided into binomial distribution, Poisson distribution, and hypergeometric distribution. So in the syllabus we will be studying binomial and Poisson distribution we will discuss. In the continuous probability distribution we have a normal distribution, we have uniform distribution, and we have exponential distribution. So in this lecture series we will discuss normal probability distribution. So in this series we will study three distributions, two from the discrete, binomial and Poisson, and one from the continuous, that is normal distribution. So now let's talk about our first discrete probability distribution. Now what we mean by discrete probability distribution? A discrete random variable is a variable that can assume only a countable number of values. So where we have many possible outcomes, or we have only two possible outcomes, that means कि whenever we have a countable number of outcomes, let's say if we'll say the on a throw of a dice, how many options can be there? So there are 6 options. So this is a countable figure. So in such case we use discrete probability distribution, where many possible outcomes are possible and only two possible outcomes are also possible. For example, of many possible outcomes, that is number of complaints per day received by a company, number of TVs in a household, number of rings before the phone is answered, then only two possible outcomes, for example the gender, male or female, defective, whether a product is defective, so we'll have either yes or no, the Boolean algebra concept. And spreads, peanut butter first versus jelly first, so you will have either yes or no option. So these are the discrete probability distributions. What are the continuous probability distributions? Just opposite to the discrete, where a continuous random variable is a variable that can assume any value on a continuum, that can assume an uncountable number of values, where the number of values is not countable and it may vary on different experiments. So, for example, thickness of an item, time required to complete a task, temperature of a solution that can vary time to time, it can change, and then height in inches. Height is also not a countable way. It also changes with the person and with the time. So these can potentially take on any value depending only on the ability to measure it accurately. So the variables which can uh, which can have any value at times, so those are called as continuous probability variables, or such distributions are called as continuous probability distributions. So now let's talk about the binomial distribution. As we had already seen, the binomial distributions are of three types. We will study only two: binomial and Poisson distribution. So let's talk about the binomial distribution today. Characteristics of the binomial distribution. So a trial has only two possible outcomes: success or failure. So we had seen into the excuse me, into the discrete distribution, that there can be multiple outcomes, or there can be any two outcomes. So binomial is of the category where we have only two outcomes, that is a success of an event or the failure of an event. So there is a fixed number of identical traits. The trials of the experiments are independent of each other, and the probability of a success P remains constant from trial to trial. If P represents the probability of a success, then obviously 1 minus P, that is Q, is the probability of a failure. As the total probability is always 1, which is the sum of the success probability and failure probability. So if we consider that success probability is P and failure probability is Q, then P plus Q will always be 1. So we can find out, if we know what is P, then we can find out Q, or if we know what is Q, then we can find out P. So these were the characteristics of the binomial distributions. Uh, Binomial distribution settings. A manufacturing plant labels items as either defective or acceptable. This is the example of the binomial variables. A firm bidding for a contract will either get the contract or will not get the contract. A marketing research firm receives survey responses in the form of yes or in the form of no only. A job applicant either be accepted or rejected. So these are all the cases of the binomial variable. Now, what is the formula? Let's talk about the formula, or let's talk about the binomial uh, distribution formula. So this is given by P of x is equal to factorial n upon factorial of x dot factorial of n minus x. This is NCx, or we can also write it as NCR. P to the power x and q to the power n minus x. So where P of x is the probability of successes in traits, n traits with probability of success as P, where n trials has been done, n is the number of trials, x is the number of successes in a sample, p is the possibility of success, probability of success, q is the probability of failure, probability of failure is q, and n is the number of trials, number of sample size. So this is P of x. Another example you can see, when we flip a coin 4 times, and in that case what will happen, n, because the number of trials is 4, so n will be equal to 4, right? And what is the probability that we get head? So P is equal to 0.5 in each case, because if we toss a coin once, so we have half probability of getting a head and half probability of not getting a head. So P is a success, that means getting a head, so P will be equal to 0.5, that is half. Q, what will be Q? Q is 1 minus P, so that is 1 minus half, or 1 minus 0.5, so this is 0.5. And X, what are X? So X are these different values, different trails: 0, 1, 2, 3 and 4. So this is the example how we can assume the variables and use these variables. The shape of the binomial distribution depends on the values of p and n. So for example, n is equal to 5, p is equal to 1. So we have the graphical representation. Okay, so these are some more formulas of the binomial distribution. You can also consider it as characteristics. So for the binomial distribution, the mean is equal to n dot p. So mean is referred here as mu. This is equal to n dot p. So you are required to please note down these formulas, as we will be needing these when we will be solving the numericals based on this. Next, variance and standard deviation. So variance basically is given by sigma square, which is equal to n dot p dot q. If you remember, what is n? The number of trials. What is p? The probability of success. What is q? The probability of failure. And standard deviation is equal to under root npq. So n is the sample size, p is the probability of success, and q is the probability of failure, possibility or probability. So for an instance, if we need to calculate mean, whenever the p and n are given, as in the last example, n was given 5 and p was given 0.1. So the mu will be the product of n into p, which comes to be 0.5. The sigma standard deviation is equal to under root of npq, where n was 5, p was 0.1. So we can calculate q by 1 minus 0.1. So this comes to be after performing the square root 0.6708. In another example, wherever n is 5 and p is 0.5, mu is 2.5, sigma is 1.118. You can see this is a very simple calculation. You can use it. We will be dealing with some more examples of the binomial distribution later. After the binomial distribution, we have a Poisson distribution. So let's talk about the Poisson distribution. Let's see the characteristics of the Poisson distribution. The outcomes of the interest are rare relative to the possible outcomes. Here they are not related to the possible outcomes. The average number of outcomes of interest per time or a space interval is lambda. So lambda is an important variable here. We will be using this lambda in our numerals. What is lambda? That is the average number of outcomes of interest per time or per space interval, that is lambda. So the interested outcomes, basically we can see the average number of interested, or we can say the favorable outcomes. The number of outcomes of interest are random, and the occurrence of one outcome does not influence the chances of another outcome of interest. For example, if we are throwing a dice and we wish that 2 occurs, so when first on the throw of the first time, if it occurs 2 or it does not occur, it is not going to affect anyhow on the next throw. So what is coming on the first row is not going to affect into the next row. The probability of that an outcome of interest occurs in a given segment is the same for all segments. Similarly, like in the first row of the dice, if the probability of occurring 2 is 1 by 6, then in the second row of dice, the probability of coming 2 will also be 1 upon 6. It will not change. So now this is the formula for the Poisson distribution, an important formula we will be using in the numerals. P of x, that is the probability, will be given by lambda t to the power x e to the power minus lambda d whole divided by factorial of x, where t is the size of segment of interest. What is the segment of interest size is given by t. X is the number of successes in segment of interest. The success, how many times we have got our favorable result, that is the number of successes. Lambda is a expected number of successive in a segment of unit data, and how many times we expect that we achieve with our favorable or expected successful segments. Then the E is basically the natural base for the algorithm. So this is the formula for the Poisson distribution. The another important formulas for the Poisson distribution are how we can find out the mean with the Poisson distribution. The mean is given by lambda t. Mu is given as lambda t. The variance variance is given by sigma square, which is again similar to the mean here. It is lambda t, and the standard deviation is given by root of lambda t, where we know that the t is number of successes in a segment of unit size, and lambda, and t is the size of the segment of interest. So we will be using these formulas into our numericals. Whenever we'll solve the numericals, we will see these distributions. So we are not discussing here the third distribution, that is the hypergeometric distribution. In the next lecture we will be discussing the normal distribution, and we will try to solve few questions on these three distributions. That's it for the day. Thank you so much. You can play, repeat, and pause your video. This video you can repeat, play, pause, try to note down the formulas which will be requiring into the next lecture. Thank you so much.